G'day guys. Okay, nearly got my voice back. It's getting better and better and better. So I'm going to make the most of it while I can. How about we'll examine what happens when we boost the output power of our metal detectors. And I don't mean boost it a lot, just a little bit. We'll see what happens. So I've got the new microphones working, and I've got one over, if I can spin that around a little bit, don't know if you can see it there, sitting on top of the battery. I'll stick my finger on it so I know where it is. There, near the speaker, so you can be able to hear this detector. This detector is a, God, what is it? 3500. And I've done a modification to this detector to boost the output power. So there's a lot of myths about detector output power. First myth, it's illegal to boost the power. No, it's not. Right, within reason. You don't want to go have it running 5 kilowatts or something and, generating harmonics all over the spectrum. But you could double or triple the power output. There's no real limitations. It's just thou shall not cause harm to other equipment. And when you're out in the middle of the bush with a magnetic radiator, it don't go too far and it's not going to cause an issue. Anyway, let's get off that subject a little bit and we'll get on to what's actually happening here. First of all, let's have a look. I'll turn this thing on. Okay, let's turn him on. Okay, I've got it on a crossover coil. I've got the gain turned down. This has got variable gain, variable this, that, and the other on it. But it's just a yardstick. This one here also has a variable power level. I didn't do it variable. It's actually, I can make it variable. But with that existing design, you can't just keep cranking the power up. You'll just overload the power supply and the whole thing will crash. It also causes other issues. You've got to do things to basically handle the extra oomph, because the more oomph you do, the more current's drawn and the more flyback you get too. So you got to watch out for that box lightning. Anyway, if I can zoom in on the oscilloscope rather than lower this thing back down, you can probably see those two bottom lines. That there is the pulses from the detector on the oscilloscope picked up near the coil. Now what I'll do, well, actually, how about we do it this way first? Just say that is, well, this is really difficult because I wish I had two cameras, or should I do this and stitch it together? I don't know. But I've got to show the coil action and the power output action. So have a look at the power. I'll just get in here and do this. Watch those two bottom lines right now. And they have dropped down, which is actually an increase in power because these are negative switched. That's 10% extra output power, okay? That's normal output power. So what we'll do, we'll swing around here. And around here, I'm going to zoom back out because it's going to be really crazy. Okay. I've got a stack of post-it notes there next to the cancel coil. I don't want to be that close in. It's ridiculous. All you'll see is the back of my hand. So it's 1 times. There we go. So what we'll do, I managed to find my 0.025 test target, which had fallen down. It's hiding down in my tools. So anyway, I've got that. So what we'll do, I'll get round this side. 0.025 tester, and I'll get rid of that because it'll be in the way. And there's a ferrite under there too, which I just knocked. Oh, yeah. I think that's the noisy ferrite, but anyway. 0.025. Just on the black here of this bizzo. You can hear it a little bit. Very hit and miss. Okay, now I'll turn the power up 10%. I'll hit the magic switch. Power is up 10%, 0.025. Now you should be able to hear that there is a definite improvement in recovery signal. Now, what does that translate at? For tiny targets, yes, it will give a depth improvement. You've got to remember too that running more power into the ground is going to ramp up the ground return signal. So you're going to have more energy available to energize things. The bigger the target actually should have the bigger benefit at fringe depth with more energy. The more energy it can accept overall without saturating, the bigger the return signal you're going to get. So for big targets, yes, more power is possibly something to be looked at. Now, you think that even this one here running 35 microsecond long pulses on channel 2, whatever you want to call it, and about 60 on the other, that tiny little target should be fully energized. And you go, oh yeah, that'd be fully energized easy. You know, you'd probably only need, you could probably energize it with about 2 microseconds of transmit time or something, not even that. And it would just give off a really good clear signal, so you can do lots and lots of multiple sampling without the big long pulses. But even so, we say, well, we'll look at what we've got here, and we increase the power, and the time duration is really long, but the signal level comes up. So even though if you talk to people, and they'll say this, oh, if you go by the book, go by the physics books and everything else, it'll say that there is probably not much benefit. And you know, hey, we're prospecting guys. The slightest extra amount of a whisper that brings a signal level up, even a tiny bit more, is called the difference between digging it or continue walking. Okay? And because a lot of the ground's been gone over these days with many various detectors, one variable that really hasn't changed much since the introduction of the GP with the 5 and 15 volt transmit output voltage is increasing that. So I can hear that easy, much easier than what I could hear it at the low power level. So we'll switch back to the oscilloscope down here, and I'll just zoom it in, and I'll just drop this back to normal power. So you can see that it does actually change. I can get more out of it, but I don't really want to with the existing power supply. I'd have to pull the transformer out of the detector, and what I would have to do then is pull the transformer. Oh, actually, I'd just get some new cores. They're only E-cores anyway, and I'd rewind it. So you'd have to put another turn or two on the device to get more power. You want to probably, say if you wanted to get the 15 volt pulse up to 20 volts, and say the 5 volt pulse to 7.5, keep the ratios correct, you would have to redo the power supply and redo the feedback system, and that you can do it. You'd probably also want to beef up other parts of the detector. You'd probably want to re-examine your damping resistor and damping resistor MOSFET to make sure they can handle the existing current load. I actually have calculated the current load at the moment of the resistor, output pulses, and its damping MOSFET it turns on and off. It actually is putting about 750 milliamps through the 1 amp MOSFET on the damping circuit. So we got a little bit more there. We can take it up, or just replace the MOSFET to a 3 amp one or something. You can also change the damping resistor from 2 or 3 watt to a 5 watt, whatever it may be, just to handle the extra flyback current. The diodes are okay. They're rated to 3 amps. They'll handle it. And yeah, probably want to put a very small capacitor across the voltage stabilization circuit on where it tries to grab it down to about 185 volts. It does rely on that MOSFET and that reservoir capacitor there. What I would do, I would get a high voltage, I'd probably get a maybe a polyprop capacitor, if you can get one rated at 250 volts. I'm just talking a small one, maybe something like half a microfarad or something, and put it across the circuit. Just remember, you touch anywhere around there, it's going to bite you. So you know, if it doesn't bleed off, you'll have that high voltage sitting there, and you'll touch it, and I keep saying, it'll send you off the back of the chair backwards. So be wary of these detectors, guys. Be very wary. That's my disclaimer. Don't work on stuff that you don't know what you're doing around, you know, high voltage. It's also that it's not AC voltage stored, it's DC. DC bites, and in a lot of cases that if you come across high voltage DC, your muscles will contract and you'll grab hold of it, which is really, really nasty. With AC, your muscles will do a spasm at the same frequency as the AC, and usually you'll let go, you'll fall off. Your hand will just slip, open and close till you let go. But DC's a bugger. There's plenty of videos on the internet kicking around about people who hitten, that's a good word, sounds like kitten, have hit or come in contact with, is probably a better terminology, pushing gantries around factories where they have 600 volt DC lines up the top to power big motors, and the guys pushing these gantries around have pushed straight up on these wires, and suddenly they got something like 600 volt DC, and you watch them, the legs go from under them, but their hands grab onto what they were pushing, the metal bars, and they don't let go. And yeah, not good, you know, especially if you see a bit of smoke start puffing up and stuff like that. Human body doesn't make a really efficient resistor, but yeah. So, well, those videos are educational. Don't do stuff like that. You know, don't go pushing big aluminium framework around a factory when it's got those high voltage wires running just under the roof line for internal powering of big equipment. So, yeah. So anyway, that's the trick. This is an old GP. We can do that in GPXs. I've been able to do that for a while. I just don't really mention it, that I can, you know, up the power level. You know, I really, even in standard form, I haven't really examined how far I can push that. I know if you push it too far, you're going to have all sorts of problems, that you're going to lose stability. The rest of the circuit won't get the right power requirements. It'll become noisy, it'll fall over. But it seems like a 10% extra output, which you can look at it this way. The 10% extra output will overcome the voltage drop of the transmit diodes. There you go. There's 2 of those in series. So you know, you're probably looking at 1.5 volt to 2 point something or other volt drop there. So you can overcome that loss from standard design. And yeah, I don't know. I know you can run the old SD 2000 at a greater voltage, Now I'll just drop this down. It's silly up in the air like now, having this up in the air. And hopefully the microphones, I'm using the new ones. I hope they sound all right. So anyway, we're going down the submarine. There we go. Bonk. So, yeah, there we go. I'm running high res, so I don't really want to see. If I go and sit in front of it, I don't know where it is. So maybe just look at the test bench or something, and we'll have a look at that detector. There you go. That's the non-interesting end. Everything interesting is on the other end. But this has had a lot of work done to it over the years, and they get handed around and swapped and sold, and this one's been picked up specifically to go deep on big stuff. So it was a good choice, actually. The fellow come across this. We can convert it to go deep. You can even see I've, at one stage, it's been in here, and I've replaced the board interconnects with things that, the existing ones, if they're all covered in white paint, you open it up and it causes a weak spot, and the paint will crack along the weak spot, and then it breaks all the interconnects. So I just replace them. It's doing it like that and not going to break again. It's much better. So if they didn't paint the things in the first place, they'd probably last forever as well. But they do. They paint them, and once you open the detector, you get a fracture line against on one of the bits of paint, cracks. That's that. So all very good. Now someone was asking me something, and I can't remember what it is now. They wanted to know something about something. I remember. It was about putting targets in the ferrites, and they said, "Oh, can you do it without using your hands?" Yeah, I suppose. Hang on, how about I try that? Well, there we have to go back up. Yabba-dabba-doo. Okay, there we go. Up we go. Lock that off. Okay. There was some other subject matter too. I just can't remember what it is at the moment. But let's do the ferrite trick. I've got to find all the little bits and pieces. Well, I've got to use my hands to pick this up and make a noise. That's weak as hell. Is that the right bit? Hang on. We crank the power up on this. That's really strange. Why is that such a... Oh, because I've got the gain turned right down. Hang on a second. Wrong one. That was... Hang on a sec. I've got my head upside down. I've got to look at it the right way. Okay, and there. Make sure I've got all the switches in the right spot on this. There. I don't know what I've got. Something hooked up weird here. That's not picking. Hang on a second. What's going on? No, it's working. But it sounds overly quiet. What have I got going on here? It's like I've got it in cancel mode running a mono. Hang on. I'll turn that down so it doesn't scream so much. Okay. Gain up. All the way. Well, it's a little bit noisier now. I don't know what's going on here. Something funny's going on. I have got this detector here set up for deep gold, so it's not really going to be picking up small stuff like that, but I mean, it's working. I'm going to have to get a bigger target for this to prove it on this detector and do a show and tell. I'm just trying to find if I've got a decent metal target we can obscure. Yeah, I'm doing it on this old figure 8 thing too. Just make sure there's no metal in there or anything causing descents. But probably not. Let's have a look. If I was doing this before, it was a lot. Yeah. I mean, it's not really a really good test for doing this. I'm just trying to find something that I can actually use to do the test. I want something fairly decent, but it's got to fit in the core, and that's the hard bit. Oh, here we go. There's a box of screws, nuts, and bolts here. So, now let's check some of this stuff out. Okay. How about, oh, that's probably too gigantic. Hang on. Okay. I know these will probably sound off. A brass nut. Ah. Right, brass nut. There it is sitting there, but you don't want me to use my hands near it. Oh God, this is going to be hard. Hang on a sec. I've got to be inventive now. You're making me inventive. Trying to think. Oh, here we go. How about I use a bit of plastic? Right. Here we go. A bit of plastic tube. We've got this in fixed tracking, so it could be anywhere, right? How about I get the brass nut and I was going to say stick it in the end. I'll stick that in the end there, the brass nut. And of course it won't. How about, I'll tell you what I'm going to do. I'm going to melt it in with a soldering iron. You can watch me do this because you'll watch me make my voice disappear again with the smoke and toxic fumes. So go around there, loosen that off. So this is when you need a damn cameraman, right? Or something like that anyway. Zoom out. Here we go. I'm going to get this and melt it into this tube as best I can. Murphy! Don't touch it too long, it'll burn my fingers. Okay, I'll do it this way, it might stick better. Okay. One brass nut stuck in the end of a tube. Let's see how we go. And around we go. I don't know where the ground balance point of this detector is. I don't really want to. Well, I could. It could ground balance it to a hot rock or something. We'll just do it anyway as is, right? So here's our nut. Okay, there it is, stuck in the tube. And because it's going up and down like that, if I did it that way, it'll be a lot louder. You watch. Donuts. It's a reactive donut. You give more of a flat side to the coil, it's going to give more of a signal. Oh, that's the doorbell. There'll be a delivery. Hope someone gets it because I'm just listening. Footsteps. There we go. I'll just check. No, it's me opening the door with a big piece of metal on it. Okay. So we got this. The thing with the nut on it, and I'll hang that core on it. I don't even know if I can do this properly, but there you go. And away drops the core. There we go. We got a delivery. Oh, very good. Okay. That'll just make that coil sound off.
Sorry.
Yeah, when you open the door, it's got that big piece of metal there, and it's going to interact with that coil. So there's a nut thing. I can't do it that way, but it's just, you know, that's much more reactive than a piece of solder by a long shot. But anyway, let's do it again. Oops. As soon as it falls off, it'll scream. You've got to keep it within the walls of the core, and this is really pushing it. So that's the story. That's how you can make things disappear. I'll try one of these little red cores. And it's sticking out too far. Here we go. Not as good as the yellow cores. And what about this thing again? I can't remember if that was this black one. It's an iron core. Drops it off, and there you go. Can we use? I'll show you something. This might be interesting. Can I do it? Yes, I can. Oh, this is interesting. Okay, this is very high permeability ferrite. Maybe I'll show you something. I'll try and ground balance this. This will be a bit of an eye opener. Okay. Hang on a sec. Into tracking. Hang on, I'll get rid of all these other cores. They may be causing all sorts of interaction. I don't know if I can ground balance this. This is the trouble with using ferrite. This is ferrite, by the way. Okay, I can't get rid of all of it. Okay, how about we do this? This will be interesting. Do you think I can make a ring disappear? Right, a ring. Put the ring in the middle of that ferrite. This needs the other structure there, but we'll do a half-assed attempt at it. Okay, let's see what happens. Nah. Can't do it, but let's see if we can enclose up the magnetic structure a little bit. I'll put another ferrite on there. The ring in the middle, damn, it doesn't go all the way. I wish I had the other half of this, because it would actually work if I had the other half. This is too open. It's too open a magnetic structure. You want a closed magnetic structure to do this. I'll get an E-core, 27 grade that is. But because it's an open structure, what happens? What about if this is bodgy as hell, but I'll try and do that as a structure. See what happens. Oh, it's heaps weaker. Look at that, if it'll go on the edge, and I just tilt it, watch this. There you go, the disappearing ring. It's still there when it's crazy. So we can diminish it depending on how you structure your encasement. Who was it coined the phrase, a ferrite coffin? Yeah, but I don't know where the other half of that core is. I probably use it. I had some of that and I used it to wind some transformers, I think. Damn. But anyway, you get the gist of it. You know, if you have enough core, I don't know, can you get a drill? Let's put some core on it. God, I feel like freaking I'm doing a bloody thing for a university or something. But anyway, I don't know if I've got enough. I haven't. Yeah, but what you can do is you stack them all on like so, right, on a drill. It should actually reduce it a bit. I don't know if it will too much. It does. It reduces it. So that's what you use to get rid of stray radiating signals. Don't use ferrite. Don't use ferrite. Okay. Let's try the same thing using some of these. There you go. More or less encased in those things they shove in detectors on the output, right? Does that do any shielding whatsoever? Don't work. Okay? Don't work. But you do have to get your core to be large enough to cover the metal so it doesn't get triggered into generating radiating eddy currents out and, yeah, basically making a ton of noise. So you want to stop the detector detecting it. That's what you want to do. So, like I said, doing the show and tell on this, I'll guarantee you that all the detector coil designs, if they got ferrites in there, will change. They won't have ferrite in there. They'll all go to iron, powder, carbonyl type cores because it's a far better option. You got to remember too, if you do the mathematics and you say, oh, but you're absorbing some signal and you're removing that much wire. Yeah, that much wire in 20 meters of wire is what percent? End of argument. So there you go. You can increase the output and detectability of very small targets by increasing power from the detector. It will also definitely light up the ground a bit more, and also it will have an effect on bigger, deeper targets that are of a very large size, as long as it doesn't saturate. See, I've got to stop talking now. There goes the voice. It's lasted me a bit. If I had something to drink, I'd be right, but nah, it's going to get croaky. Anyway, I hope the new microphones did the job. Yeah, I can feel it. Except that goes right at the back of the throat, and yeah, it just gets croaky. But anyway, was that educational? I don't know, maybe not. Just one of my funny videos I do on these things. But yeah, if you want, you can, back down to normal power levels. But yeah, you can have boost power if you want. You can do it on 45s and 5s as well. Yeah, anyway, it's just something we do. If you do want that little extra tickle. It's funny though, because if you do study up on the physics of it all, it will say, oh, very minimal on very small targets, won't do much. But it does. it's a difference between hearing it, not hearing it. And I would say it would have more influence on bigger targets at depth, especially fringe targets. And running more power again, it's going to be far better again too. So, I'll save it for another day about detectors running on 24 volts on the coil circuit. But anyway, that's that. We'll turn that off. And I better check out these deliveries. And yeah, there goes the voice. Yep, that's it. That's all, folks. Catches.